We found some really strong associations with changes in the microbiome and changes in particular species that were linked to changes in cognitive performance and also a number of different wellbeing metrics.
Your gut does so much more than just digest your breakfast. It is home to trillions of microorganisms like fungi, bacteria, viruses that collectively they influence your immune function, your inflammation, your energy metabolism, your mood, and even how motivated you feel to train. And for endurance athletes putting in 10, 12, 20 hours of training in a week, the gut isn't just this passenger organ that comes along for the ride. It is a system that is under repeated physiological stress. So to dive into some of that research today, I'm joined by Dr Matthew Cooke. Hey, Matt.
Hi, Taryn. Nice to see you again.
Matt is a registered nutritionist, integrative physiologist, and researching academic at La Trobe University. Today we're going to dive into three of the questions that he presented on at that conference. Does the gut microbiome actually change in response to training? Are those changes meaningful for health and performance? And the one that gets me really excited is, can the gut microbiome be used to predict how an individual athlete is going to respond to a training intervention? We're also going to get really practical and talk about the GI map testing that is really starting to flourish all over the internet and the health space at the moment. It's becoming increasingly popular in the clinical setting, and I want to understand and get Matt's perspective around whether it genuinely does add value to somebody's case and how practitioners should be interpreting the results. So let's get into it. So Matt, you've got a degree in biomedical science. You did your PhD in muscle physiology and nutrition, and you've published over 140 papers. What drew you specifically to get into the gut microbiome in the context of exercise and health?
Over my career, I predominantly looked at how can we enhance performance and the health of individuals. So I've worked from elite athletes all the way down to those with metabolic disease, aging, which is obviously, one thing that we really know as we get older. And it's probably been over the last sort of 10 years, we're starting to understand that the microbiome plays a really key role. And, with my research focusing on food and nutrition, obviously the microbiome plays a very important role, and there's that interconnection between food, nutrition, and obviously the microbiome. So over the last sort of 10 years, we've started to move into that area to see, well, how can we manipulate the microbiome to enhance the health and performance of these individuals? So we've done a lot of work in the active individual space. So some of the work that I presented at the conference around military personnel, obviously being very active. We've done a number of studies looking at symbiotic or probiotic supplementation to see whether we can enhance health and performance of those individuals. And some of the recent work we've sort of moved into the older individuals. So sarcopenia. So unfortunately, as we get older, we lose a little bit of muscle mass. So how can we maybe offset that through manipulating the gut microbiome?
Before we go any further, can you just briefly explain what the microbiome is versus the microbiota? Because they're often two terms that people accidentally use interchangeably, and they are really two separate things.
It's something that I always try to teach my students to make sure that they are actually separate. And exactly what you sort of said before. So the microbiota is that collection of the bacteria, the fungi, the viruses. So it's those collection of those microorganisms and the trillions of microorganisms that predominantly live in our gut. The microbiome includes the genome part of it, so the genes. So it also includes the genes and the predictive functional aspect of that composition.
Thank you for that clarification. I think it's really important that people do understand that. Let's dive into those three questions. Let's go straight into it. And the first one is, that I'd love your help to answer, is does our gut microbiome actually change in response to training? And what does the research tell us at this point?
So what we do know is that there is a bidirectional relationship between training and the gut microbiome. So there's a number of factors that influence these changes with training. So first and foremost is the type of training. So some of the studies and some of the research, what they've tried to do is split training or exercise into basically static exercise. So when we think about static exercise, we're sort of referring more to that resistance exercise versus more dynamic. So dynamic exercise being more that endurance exercise. And what they've clearly showed is that there are differences in terms of the microbiome signatures based on these types of training modalities. So they have an influence, the type of exercise. But we also know the intensity and the duration also influence the microbiome composition. So there's been enough evidence to look at how long you train, the intensity of training, where they've looked at different types of intensities. And what they've shown is that usually at the higher intensities, there are higher abundance or higher markers of microbiome health. So what we see is usually there's an increase in alpha diversity. So alpha diversity is usually an indicator of richness of your microbiome and the diversity of your microbiome and evenness, and then also increases in beta diversity, which is essentially how similar or dissimilar the microbiome is between samples. And with that, we see higher levels of your short-chain fatty acid microbiota or microbiota or bacteria. So these are the bacteria that predominantly produce our short-chain fatty acids. So these are your acetate, your propionate, your butyrate, and these short-chain fatty acids are associated with better health.
So for a triathlete that's doing a lot of endurance exercise, many hours in sort of zone 2 aerobic, what's their gut microbiome likely to look like compared to somebody that is a 100-metre track sprinter or a weightlifter?
So in general, I think sort of what I've sort of touched on before is they will likely have a higher abundance of these, I guess, healthier bacteria. And what I mean by healthier bacteria, these are the bacteria that are producing these short-chain fatty acids, which have a local impact within the microbiome. So one of those is anti-inflammatory effects, which obviously is very beneficial in the microbiome. The higher alpha diversity, as I said before, which is obviously linked to better health outcomes. So without diving into specific bacteria, I think it's more around that sort of general knowledge that their composition will be an indicator of a healthy sort of microbiome. But sort of what I mentioned before, that there is a limit on that. And I think this is an important one, is that what they've shown is that when we look at our more, I guess, ultra endurance athletes and those who are doing much heavier workloads, there is a bit of a U-shaped relationship. So we do see those benefits up to a point, and then they start to decline. So what we start to see is actually gut dysbiosis in these individuals. So basically that means an imbalance of different types of bacteria. But in saying that, even though they may have gut dysbiosis, they've actually shown that the microbiome is actually still quite efficient in what it can do.
Yeah, it's so cool. Is it high intensity is better or low intensity is better?
It's high intensity to a point. So both will have a benefit, and what they've shown is that as you gradually increase that intensity, so if they've looked at, say, no exercise, moderate exercise, and then higher intensity exercise, they've actually shown that benefit. When you get to a point and you start to get sort of, if you want to call it overloading, but there is a point there where you sort of see these ultra endurance, it can actually start to have a negative effect. So the question is, well, why is that potentially happening? So they think it could be a combination. Obviously, diet and nutrition is a really important driver. So we know that, when we're consuming a lot of these sort of processed foods in terms of your gels and those, which we know have a benefit to performance, could be having a negative effect on the microbiome. It might be higher increases or higher intakes of maybe anti-inflammatory medications, potentially antibiotics. The big thing is that we know, especially with these ultra-endurance athletes, and we've seen, there's usually a higher incidence of gut discomfort or gut symptoms, and that could be due to redirection of blood flow to the gut, which can cause that ischemia, cause higher inflammation, might impact the gut integrity wall, which is really trying to separate the gut to the blood, to the systemic circulation. So all of those factors could be having an effect.
And how quickly does your microbiome shift? Like if you suddenly went from doing Ironman training and you're doing a lot of that low intensity zone 2 work and you needed to do a sprint distance triathlon, for instance, which is really short, sharp, it's over in an hour 15, how fast does your microbiome shift in a positive or even negative way?
So in general, our microbiome is relatively stable. So we establish our microbiome probably within at least the first sort of 3 years. So those first 3 years are really critical in establishing our microbiome. And it remains relatively stable throughout life. Now, of course, there are times, whether it's taking antibiotics, a high stress environment will influence our microbiome composition. And then as we get older, so from 40 onwards, we start to see changes. I'm in that window right now. And then as we get obviously 65 and above, we start to see some bigger changes there. But to go back to your question around how quickly can it change, most of the research has shown that usually over sort of 3 to 4 weeks, if you start to change your training, usually over 3 to 4 weeks, we start to see those shifts. But it can change quite rapidly. And there was a seminal paper that was published, I think it was back in 2019. This was it made all the headlines. It was in Nature Medicine, where they actually looked at the microbiome of these Boston marathoners. They dived a little bit deeper and looked at not whole compositional changes, but they looked at particular species. And what they found was that there was this sort of one particular species, and I'm going to test my memory for this one. I think it was Veillonella atypica, and I hopefully I got pronounced that right. They actually showed there was an increased abundance of that after the race. So pre and post race, they showed an increase in abundance of this. And why it made the headlines is because what they did was they then took that bacteria and they inoculated some mice to see what effect it would have on their performance. And they actually showed that this particular bacteria could actually increase the performance of these mice. And where they think the performance was coming from was that it consumes lactate, it then produces short-chain fatty acids and therefore has that impact on performance. So certain species can rapidly change quite quickly. So whether they are positive or negative, in this case it would be positive because you're increasing the abundance of this particular bacteria. It helps consume that lactate, producing a beneficial short-chain fatty acid. Going back to what we sort of talked about before is that there are limits, so when there are really high stress loads and you're getting higher inflammation around that area, less blood flow to that area, higher ischemia, inflammation, all those sort of things, then there's possibly a negative impact on that bacteria.
I read that paper again to prep for this, and those mice had an improved performance by 13%. Yeah. So as soon as you said that, I was like, yes, good work, Matt. which is huge, right? 13% in sporting realms is massive. The second question then, which you sort of just touched on a bit, is like, are those changes that happen to the gut microbiome linked to health and performance? And because our gut microbiome is different in different athletes, like, does that matter? And how much does it matter? I think this is super interesting.
These are quite sort of large studies. So basically with these large studies, they've got lots of samples to work with, lots of data to look at these relationships. And I think what's been done in the past is looking at the relationship between particular bacterial composition and also particular bacterial species. Most of the association correlation type research has looked at its relationship between the bacteria and the bacteria composition and VO2 max. So aerobic capacity is usually one of the most sort of common ones that they will look at. And they have shown that there's a positive relationship between that. So as we see increases in, particularly around alpha diversity, as I sort of discussed before, alpha diversity as an indicator of good health or good microbiome health, that we see this positive relationship. As we see an increase in alpha diversity, we see an increase in or higher levels of aerobic capacity. But as I sort of mentioned, before, there is this sort of U-shaped relationship around that they believe that these are in sort of low to moderate sort of fitness. So when we get up to those sort of VO2 max values of, I think it's around 66, 65 or above, we actually see a decrease in alpha diversity. with this relationship. So as we get much higher, we start to see that more dysbiosis. But which would be paradoxical, because you would think, well, hang on a minute, if I'm getting fitter, shouldn't my microbiome also be healthier as well? But no, we're actually seeing a decrease in diversity. However, what we are seeing is the improvement in efficiency. So the actual microbiome becomes more efficient at these higher levels. So even though you may have, dysbiosis, which I still don't think we've fully defined what this dysbiosis is, it's essentially an imbalance of particular types of bacteria, the microbiome is still efficient. So whether it's actually detrimental to the athletes itself, I don't think we're there yet. So going back to your original question around links to health and performance, absolutely. A lot of the research is sort of more focused on that aerobic capacity, that VO2 max. But there's been a number of other studies, and one that was quite fascinating, where they actually found that the particular metabolites, so these are from the cannabinoid metabolites.
Say that 10 times fast.
Exactly right, which are produced by the gut. And these stimulate sort of specific sort of sensory neurons. And what they can actually do is elevate the brain dopamine levels, which can then influence motivation and performance. Now, mind you, this was done in animal models, so it hasn't actually been sort of tested in humans or been shown in humans, just because it's a lot harder to do that in compared to animal models. But it was quite interesting. So they're starting to show, I think, and really we're only just sort of scratching the surface in the microbiome research, but as we dive a little bit deeper, as the methods and the technology becomes more advanced, obviously with AI and everything like that, I think we're starting to see more and more relationships found between the microbiome and health and performance. We've done a number of studies, one where we tried to look at whether the microbiome, so someone's baseline composition, could it predict responses to resistance training? And we did find that there were particular species that were associated with better improvements in lean body mass gain, so as we get bigger and stronger, and also a relationship with some of the performance markers as well.
How does somebody manage that when they are needing to fuel at quite high levels to do something like a full distance triathlon? So they need some simple carbohydrates, but then they're worried maybe that is going to have a negative impact on their gut.
Well, I think this is where it comes to your whole diet approach. One of the things that we found sort of challenging with working with defence, for example, they consume, especially when they're out in the field, they consume ration packs. So ration packs are highly processed foods, high in sugars and saturated fats and all that. So basically what they're trying to do is make sure they've got enough energy. Similar to an athlete, they're trying to make sure they've got enough glucose, enough energy to be able to perform in a race and to maintain and hopefully win. So our approach is, as I said, the whole diet approach. So how can we either offset that? So what are we consuming outside of training? So are we, consuming, foods that, obviously high in dietary fiber, particularly focusing on those sort of fermented foods, your sauerkrauts, your kimchis. I'm starting to have, fermented soybean because of the benefits on cardiovascular. So what can we have, or what can we consuming in our whole diet, so outside of training, because we know that these types of easily digestible foods, quick snacks, we know they help. But how can we offset those potential detrimental effects of those through what we're consuming outside of training? And I think that's probably the biggest takeaway message here. And that's something that, when we're working with defence, for example, the same sort of thing is that, okay, well, we need to consume ration packs. How can we offset? Now, is that maybe potentially through a particular probiotic, although it is hard to find that right probiotic? Or is it outside of that? What are we consuming? What are the other foods?
We're going to come back to that probiotic question because I know you said probiotic and people are like, oh, what probiotic should we take? But before we do that, can we go back a little bit and answer question 3? So I think this is pretty exciting, and you alluded to it just before with the defence and strength training. Can the gut microbiome be used to predict how an individual is going to respond to training?
Some of the preliminary work that we have been working on, I just mentioned about the resistance training. Again, this was very pilot, very preliminary. We'd like to do it in a much more sort of larger cohort to hopefully confirm those findings. But what we did in the defence cohort was that was one of our primary questions. So to give viewers and listeners a bit of context about this type of research. So we were very interested in the microbiome. We know that stress has a big impact on the microbiome, along with your nutrition and your sleep and everything else that goes along with it. But we know that stress has a really big impact. We're very lucky and very fortunate to have access to civilians going into military training for the first time. So these are Army recruits. When they enter military training, they undergo 12 weeks of what they call basic training. This is essentially training that's learning all about military life, but it's also getting fitter. You know, you're training, you're doing a lot of exercise. So what we wanted to do was to look at a couple of things. We wanted to look at, first of all, the impact of this multi-stressor environment on the microbiome, but particularly link any changes in the microbiome to performance. Now, we focused on the cognitive performance because that's what the defence were very interested in around cognitive performance. And we also looked at different types of sort of well-being metrics during that time. So what we found was that, yes, the microbiome robustly changed during that period. We measured the microbiome over 3 time points across that 12 weeks, so start, mid, and towards the end, and we showed some really big changes in the microbiome, which is great, but is that actually linked to performance changes and well-being changes? And what we did find was that, yes, that is what we actually found. We found some really strong associations with changes in the microbiome and changes in particular species that were linked to changes in cognitive performance and also a number of different well-being metrics. Our second biggest question was, well, can we use the microbiome to predict these changes? So we used AI prediction models, algorithms, to essentially see that if we put these microbiomes compositions or microbiota compositions into these algorithms and different types of modelling, we were actually able to predict with pretty good confidence changes in cognitive performance. But what really, and also some of the well-being measures, what really excited us was that, and it was something that was probably what it wasn't our initial research question, but we had, and this was actually conducted during sort of the COVID period, but we had about 189 participants in that study. We had about 20% of those either drop out of the study or actually leave training for whatever reason, but left training altogether. So it equated to about 40 of those participants that we lost. What we were able to do with about 95% confidence is we were actually able to predict those that left training compared to those that were able to complete training successfully. One thing it did was it showed the predictive power of the microbiome. So what we're starting to see is a lot more research in this space, but I think the most important part is that with a lot of this research where we find these associations, as we know, association doesn't always mean cause and effect. So from this research is that for us in particular from this research, we're now looking at that cause and effect model. So we're going back to the animal models to see whether these particular bacteria, whether they can actually influence these performance outcomes, so cognition and well-being, as I mentioned before.
And were these guys given ration packs for their 12 weeks when they were doing their training? Like their gut's not getting that diversity through that heavy training block, so you can't say it was diet, it was more so training?
So the ration packs, where they were predominantly consuming their ration packs, we actually captured their microbiomes following roughly about 7 days of out in the field. So out in the field for that pure 7 days, they were consuming ration packs. That was all. And again, we showed some really robust changes. The most difficult part of this study was actually trying to tease out exactly what was driving those changes to the microbiome. I do agree that absolutely, I think training was having an effect. We are getting recruits coming in, varied fitness levels, and we actually looked at that. So yes, training was driving it, but I think one of the biggest factors was also stress. So what we were seeing was when you enter that military training, very stressful, completely new environment, you're probably not sleeping well, your diet's changing because now you're consuming foods that are offered. So the recruits would be consuming foods from the mess, so they would get 3 opportunities during the day. But outside that, they would probably be consuming sort of ultra-processed foods, so snacks and bars from the vending machine, just to get that energy in. So I think those robust changes in the microbiome were probably a reflection of all of those components, training being one of those, but also the impact of stress, the changes in diet.
Yeah, multifactorial, all the things at once, just one big onslaught.
Absolutely.
What do you see as the biggest gap in the research at the moment? I know you're trying to answer some of those questions, but what are the studies that need to be done for us to have really good or better information?
If we want to advance this area, now there's lots of areas that they're focusing on around still understanding what truly is a healthy microbiome, what truly is an unhealthy microbiome. We know aspects of that, but I think trying to get a universal sort of consensus on that is still debated.
Yep.
But I think where we want to see some of the advancement, especially around probiotics, and I know you said we want to sort of talk about, and we can absolutely do that now if we want to, but one of the, I think, bugbears for me when I'm reviewing a lot of these studies where they show these amazing results from probiotics, but there's no mechanism, there's no essential, as I said, cause and effect. So how do we know that the actual probiotic, first of all, is having an impact on the microbiome? And if it is, what are the mechanisms behind that? Is it increasing potential short-chain fatty acids and they're having a downstream effect on the particular outcome, whatever they're looking at? So one of the feedback that I always give around those studies is, how are these changes happening? Are you impacting the microbiome? And if not, are you potentially impacting its function? You can potentially not change the microbiome composition, but still improve the function of the microbiome. And that's something that, we've been trying to do with our probiotic studies, is trying to explore all different potential mechanisms. But the thing is, it's expensive to do that. It's expensive to analyse your microbiome. It's expensive to do the blood work. But I think it's important. If we want to advance this area, we want to understand what are the mechanisms driving these benefits.
So should you take a probiotic? As a very generalised question.
I'm not going to give a very generalised answer, but I don't want to sit on the fence on this one, but I think a lot of it does depend. Now, I'll preface it with, I'm always food first. In any of my approaches, I'm always food first. And I think look at the whole diet first. And we sort of spoke about fermented foods and increased dietary fibre and all those sort of things. Also managing other aspects of our life that can potentially influence and have a negative impact on our microbiome. So the stress, better sleep, those sort of things. In terms of a probiotic and why I'm either yes or no on sort of this recommendation is because it's trying to find the right probiotic. And I think that's the biggest challenge, because there are a lot, and I'm not going to talk about specific brands or any of that, but there are a lot of probiotics out there that to be honest, I wouldn't waste our money on buying them. They probably won't have any impact whatsoever. As I said, going back to that food first approach, your yogurts, those sort of things, having a balanced diet. But I think there would be potentially, if there is the right probiotic, or potentially I think symbiotic is usually a bit better because you're hopefully giving the food for the bugs. Then
can you explain that term?
Yes,
for people that don't know what symbiotic means.
Absolutely. So with a symbiotic, you're giving, or you've got a probiotic, which is the live organism, and then you've got the prebiotic, which, as I always say, is sort of the food for that bacteria. So you can absolutely take a probiotic on its own, and sometimes you might have a single strain, so you'll have that one particular bacteria. You might have a multi-strain probiotic, and then with the symbiotic, you've got that prebiotic, so you've got that food. Inulin's a very, very popular prebiotic with that. So sort of going back to, should we be taking one? if there is the right probiotic or symbiotic, I think it would be beneficial during those very stressful times, because we know there is that negative impact on the microbiome. So how can we bolster the microbiome up, build its resilience during those sort of very stressful times?
Excellent advice. Thank you. I love how on the fence you are still. I say it depends all the time. So it's okay to say it depends, because it does depend. And maybe working with somebody around what particular strains are beneficial for your particular use case is going to be beneficial, rather than just blanketly taking whatever probiotic you can get your hands on. There's quite a lot of research now, particular strains and particular benefits. Any particular sexy ones that you like to keep at top of mind for people?
Well, there's some really interesting and it looks like fairly strong data around I think it's the Lactobacillus plantarum, especially around performance. So there's been a fair bit. We wrote a systematic review, and for those in the audience, essentially we synthesized all the research that we could find around probiotics and its benefits on health and performance, but we particularly looked at sort of cognitive performance because it was aligning with some of the work that we were doing recently. This particular probiotic just kept appearing in terms of its benefits, and one of the good things that it did try to do was trying to look at the mechanisms on that. So that probably one of those that sort of comes to mind. But yeah, again, what we did show was that taking it during very stressful periods, and that could be during really intense periods of training, for some of your athletes who may be traveling overseas to compete or whatever it may be, these probiotics were shown to help, reduce that impact of stress.
I'll try and link that paper in the show notes so people can go and read that if they do want to get a nice overview of that space.
Absolutely.
Can we shift gears now and talk practicalities around the GI map testing? I don't know if you've heard of it before. If you're listening, it is only going to explode. It's something I did myself end of last year, I think, just out of interest, purely. N=1, you are your own experiment, but it's definitely becoming much more popular across functional medicine and sports nutrition, and I'm seeing a lot of clinics having it as part of their analysis or their wheelhouse to check. For somebody that has no idea what I'm talking about, can you walk us through what it actually is and what it measures?
I have also had one done. Fortunate.
There you go.
Yeah, very fortunate.
Like
and it was more
GeoMap Anonymous.
Exactly. And it was more out of curiosity. So yes, so going back to your question around this sort of microbiome testing, absolutely, it's exploded. It's very popular. There's more and more companies coming out being able to offer these services. So essentially what the microbiome testing does is that it will look at a stool sample. So following collection of your stool sample, you will normally send that in to the company. They will then analyze it. And depending on the company, you will get a report on your microbiome. So, one of the companies that we've previously worked with as part of our research, we were very fortunate to give these reports to our participants. And what it would give was, one, an overall, health index of your microbiome and how it compares to the rest of the population in terms of whether it's healthy, unhealthy, and it would usually give you a sort of a rating score. It would also give you your top 5 bacteria that are in your sample. Again, depending on the testing, it could also do a deep dive in those particular species. And one of the other things it can also look at is give you an indicator of sort of health producing ability. So what I mean by that is its ability to produce short chain fatty acids, its ability to regulate your immune system, which it does, the ability to regulate inflammation and inflammatory processes. So it gives you all these ratings. And most importantly, what it will do is it will give you a scale in terms of, are you sitting in that sort of normal range, above average or average, and then below average. So you'll get a fairly sort of complete report on that.
And can we take those results and have anything meaningful come from it?
And I think this is where the biggest challenge is in this space at the moment is, well, what do I do with this information? Because, unless you are testing your your microbiome repeatedly over a certain period of time, because now you've decided I'm going to change my diet or I'm changing my training or whatever it may be, you could potentially use it, like most sort of tracking systems that we have now, you could potentially use it to monitor changes in your microbiome and potentially to see whether there are, for example, if you've got, a low score in, short chain fatty acid production, maybe you could monitor that over a period of time to see whether you've increased the abundance of those particular bacteria. Something that I think is important for your audience to understand is there's a lot of variability in testing. There was a recent paper, and I'm happy to share this with the audience. There was a recent paper that came out, I think it was just this year, actually. I think they published it earlier as a preprint, but it's actually been fully published now, so it's online, so you can actually go and look. So what they did was they collected their sample. So they tested 7 different sites that would offer these services, these microbiome testing services. And what they did was they collected their samples and they made sure that they collected all these samples exactly the same. And they sent it to the 7 different companies, but they also sent the same samples to the same company over multiple times. And what they actually found was that the microbiome reports that they got back were all completely different.
Yeah, I can imagine.
Yeah. And
it's not a uniform thing.
Exactly right. And even when they sent it to the same company and they got the reports back from the same sample, it was also different.
It's Wild West, isn't it? Like, it's super exciting area of research, and there is potentially so much potential in it. But it's so hard when you get a report like that. You've done it, I've done it. I remember mine said something weird, and I'm like, I couldn't eat any better.
I was
like,
exactly
I'm a dietitian. I do all the things. I don't even know what to do with this, really. So I'm glad I saw you at the conference and be like, hey, what does this mean? Do we have to do anything about it? So, hot tip from Matt, don't do it just yet. Save your money.
I think I would save your money until we get better governance around microbiome collection, so that it is universal across, that the analysis is very similar, that we get that repeatability across. The other important thing with these companies is when they are comparing you to the average, how big is their database? So, for example, the company that we worked with, they had stool collections and health metrics and everything that goes along with it from over 10,000 participants. So their database was quite rich. But what about the other companies? What are they comparing it to? So when they're saying that you're below average, well, are you below an N of 1 like you and I? Or is it below, 10,000 participants? So I don't think we're there yet. I think the hype is bigger than the actual science at this stage. And I think importantly is, well, what do you do with that information? Unless you're, similar to what I do, I'll do my own blood testing and I'll monitor, certain blood markers and all of those. Maybe it's more out of my own sort of trying to keep track of my health and just monitor these. But with the microbiome, it's so complex that we still don't know, even though you may have this particular marker or this composition or this signature, what does it truly mean at this stage yet?
Yeah, and is what your microbiome looks like problematic or not?
Well, exactly right. And the other thing too is that the microbiome that they're analysing is essentially a snapshot of the sort of the end part of your colon. Your microbiome is and there's papers and research that's shown this, that your microbiome does differ across your gastrointestinal tract. So we're only getting a small snapshot of your microbiome along your gastrointestinal tract from stool sampling.
You mentioned the general population thing. Like, what do we do for athletes, though? Are we comparing athletes? Is there an athlete database? Because theirs is going to be different. Do we compare it and correlate it against people's VO2 maxes?
That's where the advancement is needed. You know what I mean? So, again, it would depend on the company and it would depend on what does their database look like. I would imagine that it's probably quite broad from very low fitness levels to very high fitness levels. So when people are compared to the average person, they're not being compared potentially like for like when we're talking about comparing an elite athlete to another elite athlete. Where
do you think we're heading in the next 5 to 10 years in this space? What are you most excited about?
Well, if I want to get real nerdy and very futuristic, and this is not just microbiome testing, but we talk about the whole, I like to say the whole quantified person, the whole quantified individual, where we can look at all our biometrics from sleep, diet, blood markers, all those sort of things to get that, quantified snapshot of our health. Do we in 5 and 10 years' time get to that point? Along with this, do we get monitoring that our stool sample from, and again, I'm being very futuristic here. I've been watching probably too much sci-fi, but from our toilet, can it sample? Can we get, from our stool collection, can it take a sample and can it analyze it? Now,
yeah,
obviously
Apple
we're not.
Watch.
Yeah,
I reckon it's coming.
Obviously, we're not there yet, but is that in the future, along with all the other, biometrics that we're trying to do? But I think realistically, I think this type of research, and I think I said before, we're only really just scratching the surface with the microbiome. Most of the research has predominantly looked at bacteria. What about the archaea? What about the viruses that all play a very important role? Research has shown that our archaea, which is very, very similar to our bacteria, respond more to stress versus our bacteria, a bit more resilient. So I think as we start to expand a little bit in terms of what our microbiome includes and not just bacteria, what are these other microorganisms doing? What are the viruses doing? What are they playing an important role as a whole collection? So I think we'll know more as the years go by. And like with most research, technology becomes cheaper. So we can do more research and we can do it at much larger scale. Rather than spending the thousands and thousands of dollars, we can actually test much more people at a lower cost, and that will give us a lot more information going forward.
It's only going to get worse or better, depending on which way you look at it, because everyone has wearables that measure all sorts of things these days, rings and Whoop bands and watches. Even just Apple Health has exploded over the last few years. So I reckon there will be some sort of wearable personal device where you can check your little stool sample every day and check if you're on track or not. There'll be a nice little dashboard that puts you in a little bar graph of, red, orange, green. I'm sure we're not too far away from that, to be honest, because the consumer's going to want it.
Absolutely.
Well, Matt, this has been so good. It's exactly the conversation that I was hoping for. Thank you for bringing all of that research that you've done to life and actually making sense of it for real athletes out there on the ground. The gut microbiome and exercise and all of the things that it can do for us is such an exciting space. What do we take away from that? It responds to how you train, definitely, but also to how you eat, how you sleep, and how you recover. And the not so sexy advice to get enough fibre and lots of plant-based diversity and put your fermented foods in there is probably some of the big rocks for your gut microbiome, as well as sleep and then exercise on top of that. We tend to often come back to that, I think, on this podcast, is that we talk about all these little things that you can have tiny little manipulations for in your life, and those 1%ers that you chase, although those mice had a 13% performance increase. That sounds pretty good to me. But it is about diversity and variety, getting enough fibre, managing your training load, and I guess staying fueled and less stressed are some of those fundamentals that are actually going to move the needle with your gut microbiome. If you need help with your nutrition, you know where to get it. Head to dietitianapproved.com and you can see all the ways that I can help you with that. And I'll put Matt's details below if you'd like to connect with him, and I'll link some of those papers that we talked about today in this episode as well. Thank you again, Matt. That was brilliant.
My pleasure. Thank you for having me.